Thank you so much for attending today's program, How I Killed Pluto and Why It Had It Coming by Dr. Mike Brown. I know you're going to enjoy it very much. We have a lot of people attending the program, so I'm probably going to say some of these announcements a couple of times. So I want to make sure that you all know to please mute yourself. Also, chat will be private. If you can put your questions in chat, and following the presentation by Dr. Mike Brown, I will ask the chat questions. We're also doing live transcript. So if you go to your bottom toolbar, you can see the CC, and under it is live transcript. You can click on that and you can read what I'm saying and what Mike Brown is going to be saying. Of course, as if you remember, it's not exactly perfect, but it's pretty perfect. Also, Mike Brown has let us record the program today. So if you have friends that would like to see it later, you can go to YouTube Pasadena Library and see the program. So we'll wait just a few more minutes. We usually start these programs about 3 or 4 minutes after the hour. So thank you so much for coming. I'm sure you've seen the cover of the book, the wonderful cover of the book. It is available at Pasadena Public Library for you to check out, as well as you can purchase it at Vroman's and lots of other bookstores and through Amazon as well. But we like to have you use the library or use Vroman's.
Yes, please.
Please. So while we're waiting, I want to remind you that we are in the process of the Summer Reading Club program. For the Adult Summer Reading Club program, we have featured the book Leave Only Footprints, My Acadia to Zion Journey Through Every National Park by Connor Knighton. Our friends of the library were distributing this book free to people that signed up for the Summer Reading Club. Unfortunately, all of those numerous copies have been given to library card holders, but you can go to the library and check out a copy for yourself to read, and it's a delightful read, and I hope you will participate in the rest of the Summer Reading Club activities. As you know, because you've all signed up on the Pasadena Public Library website, you can find all of our activities under news and notices, and you can see the July and August new off the shelf for all of our activities, and I hope that you'll check it out and sign up for some other ones. So I think we'll go ahead and start, but in 2005, Dr. Mike Brown shook the world of astronomy by discovering the existence of a 10th planet, slightly bigger than Pluto. But rather than resulting in one more planet being added to our solar system, Brown's find ignited a firestorm of controversy. So Mike Brown scans the sky searching for and intensely studying distant bodies in our solar system in the hope of gaining insight into how our planet and the planets around it came to be. In this quest, he has discovered dozens of dwarf planets and demoted one object from planet to dwarf planet, and is currently hot on the trail of Planet 9, a hypothesized body that is possibly the 5th largest planet of our solar system. He is the Richard and Barbara Rosenberg Professor of Planetary Astronomy at the California Institute of Technology and has been on the faculty since 1996. He's won numerous awards, including the Urey Prize for Best Young Planetary Scientist from the American Astronomical Society Division of Planetary Sciences, a Presidential Early Career Award, a Sloan Fellowship, a 2012 Kavli Prize in Astrophysics. And of course, the one as we talked about waiting for the program to start, if we have any young people attending today, be sure and do your science fair projects at school. You never know where that might lead you. Mike Brown did one in 5th grade for the science fair. So be sure and enter all of those wonderful science fairs. And he was inducted in the National Academy of Science in 2014. There's been lots of feature articles about his work in the New Yorker, the New York Times, the Los Angeles Times, and Discover. And his discoveries have been covered on the front pages of numerous newspapers worldwide. In 2006, he was named one of Time Magazine's 100 most influential people as one of Los Angeles Magazine's most powerful Angelinos. So at Caltech, he teaches undergraduate and graduate students in classes ranging from introductory geology to the formation and evolution of the solar system. He was especially pleased to be awarded the Richard M. Feynman Award for Outstanding Teaching at Caltech. He received his AB from Princeton in 1987, and then his MA and PhD from the University of California. So you know about his wonderful book, and we are delighted to be welcoming Dr. Mike Brown today. Thank you so much for joining us today. Welcome, everyone. Mike?
Thank you so much for that introduction. And let me just say, it's a delight to be talking here for my local library. My daughter and I are frequent the Hastings branch just in our neighborhood, and love everything that the library does. And I've never gotten a chance to talk for the library before. And so I'm going to talk some about, it's a little bit of a strange talk, because I'm going to talk some about the book from all these years ago, and talk a little bit about some of the science, and talk about what I'm doing these days. And so it's this weird combination of kind of science-y, booky, who knows what else talk. But I think it'll be fun to do, because one of the interesting things, somebody just reminded me yesterday that we are coming up very shortly on the 15th anniversary of Pluto's demotion, or as we'll talk about, I would call it Pluto's correct classification. So it's been a while, and yet there's still a lot of discussion of how this happened. So this was, as you've seen, this is the cover of the book. I like to think of this next slide as what could be the cover of the next book. We'll talk about how we're searching for, as my daughter likes to say, searching for a replacement for Pluto, searching for the real ninth planet of the solar system, and hoping to find it sometime soon. This whole story of Pluto, of planets in the solar system, this whole story really starts back with some of the earliest observations of looking up at the sky and seeing what's there. I want to take you back to, let's say, the year 1780. If you were in 1780 and you looked up at the night sky, you could see every known planet. You could see Mercury if you knew where to look. That's a hard one to see, but you could find it. Venus, very easy, bright in the morning or the evening. Earth, you can look down. That's pretty easy to see. Mars, nice big bright red one. Jupiter, Saturn, bright planets, and then you could, well, that's it. That's the last one. Those were the only planets that were known, until suddenly in 1781, William Herschel had built this new telescope. He starts scanning the skies, looking for stars across the sky, mapping where the stars are for his new star chart. And he looks at one star, and it's a little bit fuzzy. It's not as crisp as the other stars are. And he had the best telescope in the world, and so he could really tell when stars were crisp and sharp versus kind of fuzzy. He thought, that's weird, there are fuzzy things in the sky. Now we know them as galaxies or as comets or something. But he was careful enough to come back the next day and look at it again. And we looked at it again. He realized it had moved. And that's a game changer. Basically, if you see something in the sky and it's in a different place the next night, that means it's not a star, it's not a galaxy, it's not something really far away. It's actually part of our solar system. It's going around the sun. So Herschel immediately realized this is something in our solar system, and announced that he had found this very distant object. He could tell it was beyond Saturn, but he didn't know what it was. And in Herschel's mind, I think, it's actually hard to know this for sure, but in Herschel's mind, I don't think he really considered that there might be other planets beyond Saturn. You know, I've actually tried hard to find any mention of planets beyond Saturn before 1781 in any written record, and I haven't been able to find one. This is a good job for librarians. I have to come talk to you guys, but I can't find any indication that there's anything that anyone thought about it. And so it was. So Herschel himself thought, well, maybe it's a comet, maybe it's something. And other people are the first ones who said, no, this is a planet. You have found a planet. And he was a little bit reluctant, but finally people started saying, well, maybe it really is. And the big question in everybody's mind was, does it go around the sun in a circular orbit like the planets do? Or is it maybe like a comet? You know, if you've seen the orbit of a comet, comets are on these elongated orbits. They come in close to the sun. They go much further away. Maybe it's one of those. People couldn't tell right away, and it took a while, and it took until another almost 40 years until a French astronomer, Alexis Bouvard, who was the director of the observatory in Paris, did a full analysis of looking at all the observations of Uranus, was the name of it now, Uranus across the sky, and realized that it really is on a circular orbit around the sky. And the way he did it is, this is my favorite table in the book from 1820, is this table right here, which is a list of all the times that he found observations of Uranus. And sure, you see 1781 because that was, you know, discovery, 1781, 82, all the way up to 1819, plenty of observations all throughout there. But if you also look carefully, you see all these ones before Uranus was discovered. The earliest observation of Uranus turned out to be in 1690. It was 1690, somebody was making a chart of the sky, put a dot where a star was, and moved on. Turns out that there was no star there, and Bouvard many years later realized that it was an observation of Uranus. So he could use these observations for all these years to show that Uranus is in a circular orbit around the sun, and it's doing exactly what it's supposed to be doing. That's all this math over here on the other page is showing how it's moving around the sun. It's being perturbed by the big gravitational pulls of Jupiter and Saturn, but that's what all these calculations take into account. And it's almost exactly where it's supposed to be, but these pluses and minuses you see are deviations from where it's supposed to be. Alexis Bouvard is what we would call today a theoretical astrophysicist. I know many of them, including right at Caltech at my home institution, and just like theoretical astrophysicists today, Alexis Bouvard said, "My theory is perfect. If there are errors, it's because the observations are bad. Astronomers need to do better observations." Exactly what they would say today. And so astronomers are like, "Oh, so sorry, we'll do better." And they spent the next 20 years trying to do better and trying to make better observations. And the answer was Uranus was still in the wrong place. It was not the observations that were bad. The observations were good, but something else was going on. And that something else, by about 1840, it was obvious to most everybody that the something else that was happening was that there had to be another planet beyond Uranus that was tugging it in its orbit, sometimes pulling it a little faster, sometimes tugging it back a little bit slower. And that's what these pluses and minuses really meant. In 1840, even though everybody knew that that's what was going on, nobody really knew how to find the planet, how to use the data to figure it out. It eventually was left to Urbain Le Verrier, who also was working there at the Paris Observatory. Urbain Le Verrier worked out the math to realize that you could predict exactly where this new planet was based on these data. He sent a telegram to the observatory in Berlin, and that observatory opened up their telescope, and in a single night, there it was. Neptune, the planet Neptune, was exactly where Le Verrier had predicted it was supposed to be. It's really one of the most astounding stories in the history of science. I think, there were only 7 planets at this point, and the 8th one was predicted and found in that single night. It was not surprisingly, Le Verrier became super duper famous essentially overnight. He was called the astronomer who found a planet with the tip of his pencil. He's one of only, I think, 80 people whose names are inscribed in the Eiffel Tower there in Paris. He's got a statue right in front of the observatory, looking straight north towards Luxembourg Gardens and where, the remains of Notre Dame are these days. Pretty famous, pretty good stuff. And so astronomers saw that he got really famous by finding this planet, and overnight everybody else said, I want to do that. I want to be famous. I want to find a planet. So astronomers started predicting planets left and right. Really, there were we have gone and counted at this point, and at this point, we have found, there are probably even more that we haven't found. Again, I might need some librarians here. We have found 35 or 36 individual predictions where somebody jumps up and down and says, I have looked at this aspect of the solar system, and I now know that there's another planet beyond Neptune causing these things. And I will tell you now that all 36 times have been wrong. The very first wrong one, the very first wrong ones came about when people said, okay, look, there's Uranus and there's Neptune, and we understand those, but those observations, even those observations from Bouvard, don't quite fit right. There must be something else perturbing Uranus. There must be something else perturbing Neptune. There's another giant planet just beyond the orbit of Neptune. And the very first of these, not the very first, but the most famous of these early predictions of a giant planet beyond the orbit of Neptune came from Percival Lowell. Percival Lowell was an astronomer in Boston. He founded the Lowell Observatory in Flagstaff. I hope some of the local people have been out there. And the goal of this observatory, one of the goals, was to find this planet that Lowell had predicted. He called his planet Planet X. Everybody's now heard of Planet X and thinks that it's like a generic term for some planet out there. But for Percival Lowell, it was actually just a sequence. There was a planet. There was literally a planet P, Q, R, S, T, U, V, W. This one was X. And his prediction, he predicted where it was, and he sent a crew up to the top of Mount Wilson to take a picture of it, where he thought it was in the sky, and the picture looked sort of like this. And I don't know, do you see it? I don't think I see it. And he went back to the drawing board, kind of disappointed, because he was looking for something huge, something the size of Jupiter. Something the size of Jupiter would have been really big, would have been, as big as half the size of this image here, and he didn't see it. And so he founded this observatory. The observatory started even long after Percival Lowell had passed away. The observatory started a systematic search of the sky for this, and they hired a kid off of the farm in Illinois, Clyde Tombaugh, to search for this Planet X. And he took a picture like this. In fact, he literally took this picture, looked at it and said, I don't know if there's a planet in there or not. How am I supposed to find a planet? Well, he was smart enough to know that he couldn't find a planet just by looking at it. He took a picture one night, he took a picture the next night, and saw it move. Did you guys see it move? No. Let's try again. Very careful. One night. The next night. Maybe one more time. One night. The next night. You might have seen it at this point. I will tell you what this is. You're looking at the discovery images of Pluto. Pluto turned out to be just about where Clyde Tombaugh predicted Planet X to be. I'm going to do it a fourth time. I don't know why. Everybody seems to always get it that fourth time. There it is. Oh, maybe that's why. There's Pluto one night. There's Pluto the next night. This was pretty exciting. Clyde Tombaugh had predicted that there was a planet. Percival Lowell had predicted there was a planet. Clyde Tombaugh finds something right there. Must be the prediction. New York Times headline, 9th planet discovered, lies far beyond Neptune. So far, so good. Sighted January 21st. All good, all good. Seen in Flagstaff, correct. Special photo telescope makes thorough check, I guess. But here's where things start to go bad. Astronomers hail finding, true. The sphere, possibly larger than Jupiter, meets predictions. Possibly larger than Jupiter. That's only wrong, we now know, by a factor of 250,000. these days, I think we would probably, call it fake news or something. It's the meets predictions that actually was the part that led everybody astray. It's one of the ways that science can sometimes get a little bit off the rails. But the nice thing about science is that it will get itself back on the rails eventually. There was a prediction of a giant planet just beyond Neptune. Something was found. Clearly, it must be that giant planet. Let me show you how untrue that is. There's the picture of it right there, the picture of it right there. The size of this thing is really, well, I'll show you the size relative to what else is in the solar system. This is an interesting plot that I'm about to show you because it's something that you don't often see at real size. And I was inspired by this lunchbox that my daughter had when she was a kid because all of my friends love to give my daughter things with Pluto as a planet on them. So she had this huge collection, and the lunch boxes will have all the planets, including Pluto, which is not a planet. And they're all about the same size. Jupiter's a little bigger, Pluto's a little smaller. They're all the same relative size. This is so not true. This is the size of the planets. Jupiter's huge. Jupiter's so big it doesn't fit on the screen. Saturn is actually quite big, even without the rings on it. You never see Saturn almost as large as Jupiter because people always want to fit the rings there. Ignore the rings. It's really quite big. Uranus and Neptune, huge planets. Mercury, Venus, Earth, Mars, pretty small compared to the big giant planets, but still quite dominant. And then these little guys that you see in here are the asteroids. The asteroids, the first one discovered in 1801 series. They're tiny little things in between the orbits of Mars and Jupiter. Pluto, we now know, is not, in fact, the size of Jupiter. It's tiny. It is not this thing that kind of fits the pattern of what we've been seeing in the solar system. It's, at the time, was really kind of this lonely oddball at the edge of the solar system that really just didn't make any sense. So not only was it kind of small and didn't make any sense, if you look at its orbit, that also didn't make sense. Here are the orbits of the planets. The yellow ones are those rocky inner planets. Now there's Jupiter, Saturn, Uranus, Neptune, and if you put Pluto on there, it's weird. It goes inside the orbit of Neptune at some point. It's on an elongated orbit. And I think what's even stranger is that if you turn it sideways, compared and look at it in the plane, compared to the plane of the other things, it's tilted compared to all the other planets. It didn't make any sense. It really didn't. And for 60 years, though, it was called a planet because there was nothing else really to call it, and because it had been thought to be big at first. I often tell people, if it were discovered today, no one would think it was a planet. If it was discovered and it was realized how small it was, no one would bother even thinking about it as a planet. But at the time, people thought it was big. It was the only thing out there. So a planet had started out, and a planet had stayed in good standing until 1992. In 1992, the first kind of nail in the coffin of Pluto hit, and that was the discovery of a second object beyond Neptune. And then a third, and then a fourth. And as of today, there are something like, there are more than 2,000 objects known in orbit around Neptune. And some of them even go inside the orbit of Neptune. Some of them go much further away. And if you look at those orbits, like the orbit of Pluto, some of them are tilted, some of them are twisted. They basically make a bird's nest of orbits around there. And if you look at them from above, I think you can really see that Pluto, though Pluto made no sense with respect to the planets, when you know everything else that's out there and you see the context of where Pluto sits, you realize it really is just one of many objects quite like it in the outer solar system. This was known starting in the early, the late part of the 1990s, and it was clear the context of Pluto made sense. But the argument was still, okay, Pluto's maybe part of this other population, but it's at least the largest one. It's the most massive one out there. We're going to still call it a planet because it's big and special. This all kind of started to also more nails in the coffin of Pluto from the survey that I started in 1998. shocking to me now that it was that far long ago, using this fantastic telescope that's at Palomar Observatory. Again, I hope local people have gone and seen these telescopes. This telescope was built alongside the main telescope at Palomar, but it's kind of the sidekick. The sidekick was designed to look at big swaths of the sky and find stuff. And we spent 5 years surveying the sky and found a tremendous number of objects that were, I'll show you the sizes. There's Pluto, and here are the objects we found. Pluto's there still on the larger side. In fact, is now literally known to be the largest of these that we see. It's not the most massive. The most massive one is Eris that we found back in 2005. There are ones that are just a little bit smaller than Pluto, ones that are elongated. There's all sorts of things out there, but it was very clear as soon as Eris was discovered and it was known to be more massive and all these other ones, that was it. That was it for Pluto. Astronomers took the wise step of realizing that Pluto should never have been a planet to begin with and reclassifying it as now part of this Kuiper belt. And that's kind of where the that book of mine ends. If you're interested in the book is actually not as much a science book as it is a memoir, including I like to think my daughter is the star of it. She refuses to read it because she doesn't want to read about anything I do, but she's if you go read the book, she's now 16. Her birthday was yesterday, and you can, read from when she was very small and had very strong opinions about all this planet stuff. She said to me about 6 years ago, she said, "Dad, do you know how to make people stop hating you?" And I said, "First, I disagree with the premise of your question. But second, please tell me the answer." And she said, "Dad, what you really need to do is go find a new planet and name it Pluto, and Pluto can be a planet again." And I laughed, because, 36 people previous had predicted that there was a planet out beyond Neptune. 36 people had all been wrong. And so I did not think there was any chance that there was a new planet out there to be found. There is. Let me show you why we now are pretty convinced there's something out there. And it all started from one object that we found back at the big telescope at Palomar. And this is the object known as Sedna. Sedna is a weird object. It is goes really far away from the sun. It takes like 10,000 years to go around the sun. And it was quite a surprise when it was found. And so we kept on looking for more like it. And what we found eventually, it took a while, but found that there are other objects like it that take a really long time to go around the sun and are kind of swept all in one direction. These should be basically all pointing in different directions. This is, just for context, the blue line here is the orbit of Neptune. So the rest of that Kuiper belt, those other objects, are all really close inside here. And these are the ones that go really far away, 10,000 years, 15,000 years to go around the sun. They all look like they're pulled off in one direction. Quite strange. When we realized this, a colleague of mine and I, Konstantin Batygin, who back when we used to have offices that we worked in, had an office just down the hall from me. I walked down into his office and said, "Hey, Konstantin, what is going on here?" And we knew that anybody who saw this would immediately jump to the conclusion, "Oh, it must be a planet," because this is what astronomers do all day long. We decided we are not going to say, "Oh, there must be a planet," because we know there are no planets out there to be found. So let's figure out what's really going on. So we spent a year trying every possible other thing we could think of. We tried looking at the effect of the Milky Way galaxy, of the masses of the objects. We tried everything we could think of, and we finally came to the conclusion that it must be a planet. There must be a planet to keep these things all aligned like this. And we thought, but we don't want to, go announce to the world, be the 37th and 38th people announcing to the world that there's a new planet and be wrong like everybody else. So we kept on working. We did some computer simulations trying to understand, we thought, okay, it must be that there's a planet on an orbit that goes around this and kind of hugs all these. So let's do a computer simulation of what that would be. And it looks sort of like this. So here's the simulation. We take Neptune in the middle. You can hardly even see Neptune in there. This line is the orbit of a planet. You don't see the planet itself, you just see the orbit. These blue lines are the orbits of these test particles we put into the computer, just things on elongated orbits that we let be gravitationally affected by all the planets. and we're looking to see what happens. First thing that happens is most of them go away. We started out with a lot of these blue lines, and now they're almost all gone. And the reason is because crossing the orbit of a planet is bad news. You're going to get close to it. It's going to get close to you. You're going to get ejected. So we thought the only things that were going to live were either close in and never cross the orbit of the planet. That's kind of these green ones, or that they live over here and get stuck over in this region over here. And so here we go. Let's look for things that get stuck. Here's one that, no, it doesn't do it. Here's one, no. One of them gets stuck. This one gets stuck. Nope, doesn't get stuck. This one, no. Everything, when you see them disappear like that, it's because they've gotten ejected. And so the bad news is we were totally wrong. Nothing gets stuck over here on this side of the solar system, but they get stuck over here. We were shocked when we saw this at first. In retrospect, it all made sense, and we thought, we should have known this. It's just the way that that orbits in the solar system work. Yes, these things all cross the orbit of this massive planet, and yes, that's bad, but they do it fast. The way that orbits work in the solar system is an orbit is the object goes really slow out here and then goes fast and comes back out. Slow, fast, and comes back out. That means, and these do the same thing, that means that when things are in here, in this part, it's really fast in through here and then spends most of its time out here. The planet does the same thing, really fast in through here and then spends all its time out here. That means that these objects that are on the opposite side of the planet, of the solar system as a planet, spend most of their time as far away as possible from this planet. If you tried to get something that was on an orbit like this, it would spend most of its time close to the planet, and that would be bad. And so those are the ones that don't last for very long. These guys are the ones that last long. So what that tells us is, if you see orbits that look like this, which we do, that means that there's a planet on an orbit that looks something like this. And the other little fun part of it is, if you look at them sideways, you can see that these objects that are swept backwards are all tilted, just like Pluto is tilted. These are all tilted in one particular direction too. So we can tell that the planet itself is tilted there too. This was pretty exciting. So Constantine and I thought, okay, are we yet ready to jump up and down and say there's a planet out there? And we were super reluctant, because we did not want to be the 37th and 38th people to say that there's a planet out there to be found. And so we thought, okay, the right way to do it, the way that really that you convince yourself that what you're seeing is correct, is that you make a prediction. The prediction that we made, well, one prediction was that we're going to find more objects like this, and that's going to take a while to come true. But what we also realized is that from our computer simulations is that there should be other types of objects that are other types of orbits that Planet 9 makes. So I'm going to try to show how this works on the video, if you watch the video now. So if the sun is here, the planet does this, the other objects do this. There should be another set of objects that go from here, going like this. The planet twists their orbits perpendicular and then twists them perpendicular again. So they are on orbits like this or like this. And there have to be these objects. And we searched and searched and searched. And shockingly, we actually, that's what I just showed. Okay, let's do that. Shockingly, we found them. There are these objects on these orbits exactly like we predicted them, perpendicular in the direction of these, and also perpendicular in the direction that they go through the solar system. This is a pretty amazing thing. Nobody knew where these things could possibly have come from, and the only viable explanation for these is also having this planet out there. So this is the point where we went public. We wrote a paper. We said, we predicted the existence of this giant planet out there. And I hate to tell you that the 36 people before us had predicted the existence of a giant planet out beyond Neptune, and they were all wrong. And we're right, even though they were wrong. But we're right, even though they're wrong. It's just really true. There is really almost no way that there can not be a giant planet out there in the outer solar system based on this. So let me show you a few more things, such as, here's what we now know today. This was our original prediction, was based on a small subset of objects. Now there are even more. These are all the objects on those distant orbit. Again, they're all, even the new objects are almost all swept off in one direction. there's one object that's not, this is the yellow one is the actual planet itself. There's one object that's going in the other direction. That's good. Our theory actually predicts that there should be some objects going off the other direction too. So far we have met every prediction that that we had, and the theory holds together really well. And I have to tell you, I am essentially 100% convinced that this planet is out there. Let me tell you a little bit about it before I tell you how the search is going. When we originally talked about it, we said it was something like 10 times the mass of the Earth. And 10 times the mass of the Earth is really interesting. It's midway between Uranus, which is 14.5 times the mass of the Earth, and Earth, which is precisely 1 times the mass of the Earth. What's interesting about this is that the solar system didn't have, that we knew of, anything between Earth and Uranus. And yet, that is the most common planet around other stars in our galaxy. So I used to teach classes about our solar system, and I would say, wow, isn't it weird? You know, if you look at other stars, they tend to all have planets in the sort of 5 to 10 times the mass of the Earth range, and we don't. What's weird about us? And the answer is probably nothing. Planet 9 really is there. Actually, Planet 9 is probably not 10. We have now done a better job, and I think it's 6. 6 with an uncertainty of maybe 1 of where it is. And I think it's out there ready to find. So 6 times the mass of the Earth. We don't know precisely what kind of planet it is, but we think, based on the fact that it's 6 times the mass of the Earth, that it's more like a miniature version of Neptune than it is like a giant version of the Earth. I don't think it's a large rocky or large body, icy body out there. I think it's an even larger gassy body like Uranus or like Neptune. But until we find it, we won't know the answer to that for sure. Okay, so if it is 6 times the mass of the Earth and a gassy body like that, how does it fit into this whole scheme of the solar system? You know, is this one of these things that we're just going to a little bit bigger than Pluto, and we're going to argue about whether it's a planet or not for the next 15 years? And the answer is no. This is huge. This is the legitimate 9th planet in the solar system. It's the 5th largest planet in our solar system, and it really is the thing that you would expect in the next belt beyond this belt here. So it really is kind of makes the pattern of the solar system finally make sense again. So we actually published this original paper 5 years ago, more than 5 years ago, 5.5 years ago now. And we know there's a giant planet out there. How come we haven't found it? Well, the answer is we're not as good as Leverrier. Leverrier could, we might be as good, but we're not as lucky as Leverrier. Leverrier could actually predict exactly where Neptune was, and there it was. But he had one advantage that we don't have. He actually had data from Uranus and Neptune going all the way around the sun. And that meant that he could look at the effect of, did I say Uranus and Neptune? He didn't have Neptune, obviously. He had Uranus going all the way around the sun. That means he could watch the effect of Neptune from all these different directions as it went around the sun. We really don't, we only have a snapshot. These things that we're using to point to Planet 9, they have 10,000 year orbits around the sun. If you can give me 10,000 years, I will point you to precisely where Planet 9 is. Right now, the only thing we can tell you is the orbit of Planet 9, and we don't know where in its orbit it is. So there's a lot of sky to look at, but we've spent a lot of the last 5 years not just looking at the sky, but really trying to understand precisely where it is. And so we've actually had to develop new analysis and mathematical and computational techniques to take these observations that we have and turn them into predictions in the sky. And we have finished. I'm pretty excited about that because we actually just finished this spring, and this map of the sky, I like to think of this as the treasure map. This map of the sky is the best predictions of where to look in the sky to find this 9th planet. This is a map of the whole sky, flattened out, projected. Imagine that this is a map of the whole Earth. This would be the whole globe of the whole Earth. This is the equator of the sky. These big thick lines, this region in through here is the Milky Way galaxy. This line here is the path of the planets. And these colored things are where Planet 9 is supposed to be. The more red it is, the more likely it's there. The most likely spot, we'll talk about the spot across here, is in the northern part of the sky. It's nice because we're in the northern part of the sky, and sort of poking through the Milky Way galaxy. Less nice because the Milky Way galaxy has a lot of bright stars in it that makes it a little harder. But this is where we're now looking. We not only know where to look, but we also know how far away it is and how bright it is. How far away it is, the sort of mean distance at these locations is something like 400 AU. AU is the distance from the Earth to the sun. So it's 400 times the distance of the Earth to the sun. For context, Neptune is 30. So it's something like 15 times further away than Neptune. It's way, way, way the heck out there. But it's big, and so it's not too faint. The bottom plot shows you how bright it might be. And for any astronomers out there in the audience, I bet there's somebody in the audience who has a telescope that can see 18th or 19th magnitude. So faint is on top. Astronomers are crazy. Small numbers mean bright. Big numbers mean faint. Blame the Greeks. It's not my fault. But I bet there are astronomers out there in the audience who can see 18th, 19th magnitude things with their backyard telescopes. 20th magnitude, we can do with a lot of telescopes on the Earth. And 21, 22 starts to be, you kind of need a big telescope. And then 24, 25 out here, that's some of the biggest telescopes in the world. But in this region where I think it really is, it might be 21, might be 22, something like that. So we're off on the search. I'll just finish up telling you how the search is going. You've seen this picture before. The first telescope we're using to search for it is this exact same one. It can sort of cover this region up to about 21. So anything that's this brightness in through here, we'll be able to find with this telescope. And I'd actually literally just finished this 2 weeks ago, and we didn't find it. So it's not on the brighter side. Sad news. Doesn't matter. We're still going. Here's some more telescopes. These are the Keck telescopes, and why my favorite telescopes. We're not using them. Our next telescope is over here on the island of Maui. This is Mauna Kea. It's a telescope on Haleakala. It's called Pan-STARRS. It's covering the whole sky to about 22nd magnitude. So again, we'll cover that whole region there. The other telescope we're using is here. This is the Japanese National Telescope, the Subaru telescope that we're going to use. It's one of the larger telescopes in the world, and we're going to use it to cover the faint ends. So between all these telescopes, we and other astronomers, I think, are going to be able to find it in one of these. Where are we looking? Well, if I could pick any spot in the sky, I'm just going to end on this thought of where it should be in the sky. The spot in the sky that I think most people recognize. Most people would say that if you ask for a constellation, they'll say the Big Dipper. But actually, I found that a lot of people still can't find the Big Dipper. But almost everybody, if they look up and they see Orion, they recognize Orion, and you can see it from pretty much everywhere on the Earth. You can see Orion, and in most cultures, it has been declared to be some sort of warrior. You can see Orion here with his belt. That's his armpit. Betelgeuse is Arabic for armpit of the giant. And usually he's shown as either having an arrow, a bow and arrow, or a shield, and he's fighting Taurus. Taurus, the bull, you can't really see it in this picture, but his horns are here. The Pleiades is his brand, and there's this cosmic fight in the sky. And it turns out that this is it. This is where Planet 9 is. When we find Planet 9, you can see all the extra stars here. This is the Milky Way galaxy. That swath of the sky is really right in the middle of this cosmic fight between Orion and the bull. And and that tells you when we're going to find it. You can't see that swath of the sky tonight. If you think about when do you see it in the winter. You see it in the early morning of the late summer skies. You start to see it earlier and earlier as fall goes on. It's always been a sign to me that winter is coming when I get my first glimpse of Orion. But now I think of it as Planet 9 is coming. It's there. It's going to be found somewhere in this region, I bet. And I think it's going to be found sometime in the very near future. So, we started the story with Pluto, how I killed it and why it had it coming. And I just think this story just worked itself out perfectly. We kind of needed to kill Pluto to really understand what the solar system was like. And we kind of had to get rid of that business before we could move on to the next thing in the sky, which is how we're going to go and find the real Planet 9 and start to learn even more about what all these planets are like out there. I'm excited. We're going to find it soon, and I hope you guys are excited too, and we'll pay attention as we go along there. And I am now happy to take questions.
Mike, I think Christine got kicked out and is trying to rejoin. So
Okay.
I'm going to ask the first question that I see in the chat until she gets back in, which
Okay.
is, do you have a name for Planet 9, or would that be presumptuous?
So presumptuous, yeah, that's a good word. So we do not have a name because, you know, astronomers, shockingly enough, are a superstitious lot. I blame it to the fact that we're impacted by the vagaries of weather in everything we're trying to do, and I think that sort of makes you more superstitious. So, you know, we all have our ceremonies that we do to the weather gods and everything else. But one of my very strongly held superstitions is, if you name it, you will not find it. So and so we don't even. I mean, we honestly have not considered any name whatsoever. And if anybody wants to tell me one, I will take my headphones off and not listen. Because I don't want to hear it. But as soon as we find it, it'll be good. I love the naming of these things. If you go back and actually if you read the How I Killed Pluto book, I talk a lot about the naming of the other large Kuiper Belt objects. The naming is really important to me and fun, and I think historically significant and culturally significant. So it will be an important thing, but not till we find it.
Thank you. Let's see. What is the most likely cause? What would be the most likely cause for Planet X to have a different orbital plane?
So first thing is, it's not Planet X. We have to get that part straight. Planet X is a real prediction from Percival Lowell, and there is no Planet X. So this is Planet 9, which is a different thing from Planet X. So we don't know the answer to this question, but that doesn't stop us from speculating. That's what we like to do best. So right now, what we see is the gravitational effect of Planet 9. So we know it's in this tilted, elongated orbit. But we can ask ourselves how it most likely got there. And I think that the answer is that it formed much closer in our solar system, probably formed in the region of Uranus and Neptune. And then it got a little bit too close to Uranus or Neptune, or maybe even Saturn, and got kicked outward. And when it gets kicked outward like that, it can get kicked a little bit high or a little bit low. And it's basically been lurking on the edge of the solar system ever since, just waiting for somebody to notice. That might not be true. So there's at least two other possibilities. One is that we captured it from another star. The star came by and we stole its planet. The probability is not super high, but it's not impossible. And the third one, that I think is pretty implausible, is it actually formed out there and it's been kind of knocked around by the gravitational influences of other stars, and that's why it's tilted. But I bet it's the first one. I bet it formed near Uranus and Neptune and just got kicked out there.
Wow, that's really interesting. Thank you. Let's see. Do you think Planet 9 is an interloper captured by the sun, or a previous inner planet that got ejected?
Yeah, so that's basically, that was the answer to that question.
Yeah. Nice thinkers out there. Let's see. You know Planet 9's orbit. Do you know where it is in its orbit?
Right. So that's the issue, is that unlike Urbain Le Verrier, we only know the orbit, not where in the orbit. If we knew where it was in the orbit, we could call up the Berlin Observatory and say, go point here, and they would find it in one night like they did for Neptune. But we don't. So we know the orbital plane and where it is. So that basically gives us a swath in the sky that we have to go search. Makes it a lot harder than it was for Neptune.
How do we know Planet 9 is bright enough to see? You seem pretty confident you will find Planet 9 soon. Can you put a confidence level or percentage on that?
No, but I can tell you. So how do we know it's bright enough to see? So there are a couple of assumptions in there, and this is why I'm not going to put a confidence level, because there are assumptions and there are reasons those assumptions could be wrong. So here's what we know. The only thing we know well is its orbit and its mass. And so then the question, and so that means we know we know how far away it is at different points in the orbit, and we know its mass. Taking its mass, we can say, okay, we think it's a giant planet like Neptune, and therefore, if it's six times the mass of the Earth, then it's probably something like 2 times the radius of the Earth. That's what we see throughout the galaxy, so that makes sense. Is it true? That part could be wrong, but let's go with it. And then the other big question is, we know how big it is, we know how far away it is, but the other question you need to know is how reflective is it? So it could be made out of, it could have really bright clouds in its atmosphere and reflect all the sunlight back. That would be great. Could be really dark. I mean, if it were actually not cloudy at all, but were actually a solid body, it could be, as dark as coal. That would be really bad news for us, because then everything I said about how bright it is would be wrong by factors of 2 or 3 or 4 or 5. I hope that's not true. We make what we think are reasonable assumptions, and we give ourselves some room to be wrong. But there's always the chance. It's the hardest thing about making these predictions is making the predictions. We don't know. This is a planet that we've never seen before, of a type that we have not seen up close in our solar system before. Often when we think we know what we're predicting and we think we know what we're talking about, we often turn out to be wrong. So it wouldn't surprise me too much if some of the things we think are going to be true just turn out to be wrong. So I hope we find it. I think we will, but can't guarantee that.
Okay, we have, let's see, could the interstellar wind be the reason the outer Kuiper belt objects are swept into one direction?
Yeah, so we are inside of a bubble, a bubble caused by the magnetic field of the sun, within the magnetic field of the entire galaxy, and we're moving. This bubble that we're in is moving through the magnetic field of the galaxy, and so things that go further out, like these other objects, leave our bubble, and then they're affected by stuff from the outside. But there's so little out there. I mean, it's a fascinating place to study, and we we hope to have spacecraft out there to see what's going on outside of our bubble. But it is like, a little piece of hydrogen hitting you every once in a while. So there's really no effect on the positions of the orbits caused by leaving our own bubble. It may change the surface may darken differently, or it might get eroded away a little bit or something, but it's just not nearly enough to have any effect on what those orbits are.
What is the cat's name?
The cat is Rosie. All of our cats are World War II characters, and that was Rosie the Riveter. She is our bratty princess cat of 3 of them that are around here somewhere.
All right. When you are looking out into space, how long do you actually do so at any given time?
It's a really interesting question. And so it depends entirely on which of those telescopes we're using. And so I showed you 3 because they're sort of 3 different scales. So some of them, that one that had the nice black and white drawing, I should have mentioned that nobody sits there and looks through it like the guy with the pipe anymore. These are all done with big digital cameras, very much like the type you have on your cell phone, only bigger. And telescopes like that automatically scan the sky night after night after night after night, taking pictures of everything. And so we get to basically use years worth of data from those telescopes to try to track this thing down. So that's fantastic. The other telescope that was on the distant island on Maui, on Haleakala, Pan-STARRS telescope, does the same thing, night after night after night after night after night. When you get to larger telescopes, the other astronomers want to use those too. Very irritating. I'm not sure why they think they should be allowed to do that, but they want to use the telescopes too. And so it is a rare and precious commodity to get to use one of those big telescopes. So we, our search for Planet 9 on the Subaru telescope, we have over 5 years, we've had something like 14 nights at the telescope scanning the skies with that. So it's rare. And then when we're on it, we're on it all night long. But it's not as frequent as I wish it were. If we just, if you could just give me the Subaru telescope, we could find Planet 9, even if it's on the faint end of what it could possibly be. But nobody's willing to just give it to me just yet, apparently.
Okay, can Planet 9 be considered a planet even though its orbit goes into the Kuiper belt?
Absolutely. So Planet 9 is, in many ways, I like to think of it as the most planety planet out there. Its orbit actually does not go into the Kuiper belt. If you looked carefully at what the orbit does, it doesn't go into that region where Pluto is and that nest worth of stuff. The closest it ever comes to the sun is probably 250 astronomical units. So again, like something like 7 times further away than Neptune. So really far out there. And it does exactly what we think of as planets doing. It gravitationally dominates its region of the solar system. I mean, the reason we know it's there is because it's gravitationally dominated. You saw that early computer simulation and how very efficiently Planet 9 clears out everything that's around there, and only a few stragglers are left over. So it's behaving just like we know planets should, and it's very, very much fits the new definition and the new concept of what a planet is. And I should point out that the new definition and new concept are not new. They're basically codifying the concept of a planet that we really kind of developed in 1850. So there's nothing new about the definition of planet. There's just a better understanding of how to talk about it. But it's the same idea that's been around for 170 years.
Okay, a few more questions. We're going to end right at 6. I apologize if my roaring air conditioner is causing sound issues, but what telescopes are you using right now?
So it's those 3 that I showed are the ones, the data that I'm currently analyzing. So the little one at Palomar, we just finished the analysis. The Pan-STARRS one on Haleakala, I'm actually analyzing those data right now. And whenever we get a chance, we go off to the Subaru telescope and analyze those data too. There are a couple other astronomers who are looking with different telescopes. And again, everybody now has this treasure map of where to look. So everybody mostly knows where to go look in the same place. And some other telescopes around are looking too. One pretty large telescope in South America is taking a look for it too.
How much analysis is manual versus programming?
Almost none of the analysis is manual anymore. So it's when people ask what I really do, I sit around and I write computer programs all day long. That is my job as an astronomer, is figure out ways to analyze digital data with increasingly sophisticated algorithms and banks of computers. It doesn't quite have the romantic sound of sitting on the mountaintop, watching the sky and smoking your pipe inside the observatory dome like everybody apparently used to do. But I tell you, it's still, to me, as exciting as anything I could be doing. Getting those data, looking at what's happening, finding things for the first time. I don't care if I'm there. I don't care if I'm sitting here at home, sitting in my office, seeing something on the screen that no human has ever seen before. Always is just this feeling of electricity that comes through you that's as exciting as can be.
Okay, I've often thought that the questioner has often thought that if the astronomers of Clyde Tombaugh's time had the technology and imagination to find multiple Kuiper belt objects, they would have realized it wasn't a planet in the traditional sense, and it wouldn't have been mislabeled. Have you run across any evidence that astronomers of that era started looking for similar objects at that distance, or did they just mistakenly assume it was a large, very distant object, as Lowell believed?
No, this is a fantastic question. The first astronomer who kind of worried about Pluto being kind of small and not fitting the prediction was Clyde Tombaugh. So Clyde Tombaugh, after finding Pluto within months of starting his survey, he spent decades scanning the rest of the sky because he thought that his planet X was still out there to be found, but he also wondered if there was anything else out there. What's funny and why I love this question is that there are other Kuiper Belt objects that could have been as bright as Pluto, could have been found by Clyde Tombaugh had they just been in a different place in their orbit. Clyde Tombaugh could have found Eris. Clyde Tombaugh could have found this other one that I found, Maki Maki. Clyde Tombaugh could have found Haumea had any of those been at their closest approach to the sun. And I think you're 100% right. I think that finding Pluto, people were like, oh, planet. And then you find one other object on an elongated orbit that looks the same size and kind of crosses the orbit. You're like, oh, it's not a planet. This is just like the story of the asteroids all over again. And it would have been obvious instantly. And that didn't happen just because of the bad luck of where things were in the sky. But I love that question. I think you're 100% right.
Okay, we have one last question, but it is 6 p.m., so I want to be cognizant of your time and everybody else's time. Should we recommend somewhere people can go or a website or contact information to ask questions or?
I am happy to ask.
Okay.
If there's one more, let's just do it. Okay.
How do you estimate the orbits of 10,000-year objects with so little data points?
So it's also a really great question. It's not that hard, strangely enough, and the reason is physics. Physics works really well. So if I put an object going in orbit around the sun, and if you told me precisely where it was, and precisely how fast and in what direction it was moving, it's all I need to know. I can predict its orbit for the end of time. And because that's how physics works. All it is, it's the same way that, if I throw an object, you see where it is and you see how fast it's going, you can predict where it's going to land pretty precisely enough that you can catch it, which is nice. So all I need to know is where it is and how fast it's moving, not where it's been for the past 10,000 years. Now, those things are not instantaneously easy to measure because we're looking pretty far out in space and we only get to look in 2 dimensions, not the 3rd dimension. But over a couple of years, 4 or 5 years, we can see things from enough different directions and watch it moving across the sky enough that we have enough information about its position and speed that we can estimate that orbit pretty well. So those 10,000-year orbits, they might be 8,000, they might be 12,000. That's kind of our uncertainty there. We know really well where they are now, and their outer edges are a little bit uncertain, but we're pretty good at it.
Okay, well, is there somewhere you can recommend people can go specifically on the Caltech site, or is there somewhere people can go for more updates and information? There's
a ton of information. If you find my website, easy, just Google Mike Brown Caltech, you can track me down. You can find some of our updated stuff on Planet 9. You can find out about Pluto. You can see links to most of those things. So that's a good place to start your search.
Okay, great. Well, everybody, we're recording this. We'll send it out to everybody who registered, and I'll include his website for you in the email. And we really want to thank you so much for a very fun, fascinating talk today. And I know Christine would be effusively thankful, and so am I on her behalf. And we're really glad everybody came and joined us today. Thank you so much.
Yeah, thanks everybody for coming. It's my pleasure to be here, and I'm happy to do it.
Okay, well, thanks everybody, and have a very good evening, and keep looking up. All right. Good night.
Good night, everybody.